Some students add when what is required of them is multiplication. Sometimes they multiply when what is required of them is just addition. Many times, students are confused as to which number operation is to be carried out. What exactly should we do or should students do so that they can identify the type of number operation required to be carried out when a particular number expression is written as a challenge to them? That takes us to lesson objective number 10, how to recognize the type of number operation. This section is very crucial yet interdependent with others. In this section, we learn how to recognize addition, multiplication, and division, and even mixed operation. Please sit back and cooperate with me as I explain how to know that what is required in a particular number operation is addition or multiplication, division, or even an outright mixed operation. Please listen to me. In this section 10, let us learn how to recognize the type of number operation. That is, when we are given a number operation to carry out, how do we find out if what we are supposed to do is addition or multiplication, division, or even a mixed operation? As beginners, we can get confused as to which one we're going to carry out. A mixed operation is a type of operation that contains some or all of addition, multiplication, division. I failed to mention subtraction. That is because subtraction is just addition. Therefore, the three major operations we carry out in basic arithmetic are addition, multiplication, and division. When two or all of them are involved in one operation, we call it mixed operation. Now, we say, with the following number expressions, could you tell whether you should add, multiply, divide, or carry out mixed operation? I hope you know what I'm trying to ask you here. Please watch these four operations in numbers. Minus 2, minus 2, minus 2, minus 2. You have four twos. What are you going to do with them? Are you going to add them? Are you going to multiply them? Are you dividing them? Just what exactly are you going to do with them? As a beginner, you may be confused as to what to do. If you don't know how to know what we're going to carry out here, this section is for you. We want to find out how to know the number operation required to be carried out for a particular case. Look at the rest. Minus 2, bracket minus 2, bracket minus 2, bracket minus 2. Are we adding them? Are we multiplying them? Are we dividing them? That is, are we carrying out division with them? Anyway, if you cannot tell, like I said earlier, this section 10 is for you. What about this, please? Minus 3, bracket minus 8, divided by 12. 3, 8, 12. What are we doing with 3, 8, 12? Are we just adding the numbers? Are we multiplying them? Or are we carrying out division with them? Anyway, sometimes we carry out more than one type of operation with a particular number expression. Do you think that this contains just one type of operation or more? If you don't know, Like I said earlier, this section is for you. Take a look again at this number 4, 3 plus 5, bracket minus 3, divided by minus 1. Are we carrying out addition with 3, 5, minus 3, and 1? Or are we carrying out division with them? Or are we multiplying them? Or are we carrying out mixed operations with them? Again, can you tell what all these 4 expressions require of us? Please pay attention as I explain how to know the type of operation required to be carried out when given such number expressions. These 4 are just examples. Please be patient. Now let's turn attention to addition. How do we know that a particular number operation given to us will require addition? It says, if plus or minus comes between numbers, I hope you're following, or comes between terms, with no other signs separating them, what is required is what? Addition. Did you understand that statement? Okay. Let us use the following number operations to check if we understood it or not. Perhaps with my questions that come afterwards, you'll be able to probe yourselves as to whether you understood this statement made earlier in connection with the number operations that follow. It says, which ones among the following operations require only addition? That is, these operations A, B, C have been given. Do they all require addition? Is there any of them that does not require addition? Let us start with the first one, 2 minus 5. What are we doing with 2 and 5? Are we going to carry out addition with them? Are we going to carry out multiplication with them? Are we going to carry out division with them? Let us go back to how to know if it is addition. This is a number, and this is a number. Something should come between them with nothing separating them again before we can carry out addition with them. Please, what is that? It is either plus or minus comes between numbers before we conclude that what is required is addition. This is a number and this is a number, and between them is just this minus. Nothing separates these 2 from this minus, and nothing separates this 5 from this minus. The implication is that what is required here is addition, which means what is required here is I have 2, I'm owing 5, add them, that is combine them. I hope you understood it. What about this one, please? 2 bracket minus 5. Are we going to carry out addition with them? Notice that the same numbers which are here are also here, but there is little difference between the expressions. That difference is that here we have a bracket. Between 2 and 5, we still have minus, but there is this caveat, a proviso. What is it? That if plus or minus comes between those numbers and no other sign comes between them, then you can go on and carry out addition. But just watch this one. 2, 5, minus comes between them, but unfortunately this bracket separates this 5 from 2 and separates 2 from this minus. It therefore means that something is coming between them apart from this minus. Only minus or plus should come between numbers with no other sign coming between them for us to carry out addition. Therefore, what do you think is required here? Is it addition? Certainly no. Therefore, what is required here is not addition. What about this one? Minus 1, minus 1, minus 1. Are we multiplying these numbers? Are we subtracting? Are we dividing or adding? Please, again, let us check in the light of the instruction or the conditions given. Plus is not here. What is here is minus. Then this minus, for instance, is the only sign between this 1 and this 1. This minus is the only sign between this 1 and this 1. Nothing else separates them. Therefore, as before, we conclude that what is required here is addition. It means I'm owing 1, I'm owing 1, I'm owing 1. Combine them. That is, add all the things you are owing. Now let's see more examples of operations in which what is just required is addition. I believe you'll be able to understand why we conclude that what is required in each of them is addition. Please let us see them. These more examples are here. That's number D, minus 3 plus 5, minus 1, minus 3 plus 9. What we are required to carry out here is pure addition. Between 3 and 5, only this sign is written. Between 5 and 1, only this sign is written. Between 1 and minus 3, only this sign is written. Between 3 and 9, only this sign is written. So when this sign or this sign alone comes between numbers in number operation, what is required is pure addition. Look at this one too. Minus 2, minus 2, minus 2, minus 2. This looks like the first example I gave to you. The first challenge I gave to you just before now. Do you remember? Yes, minus 2, minus 2, minus 2, minus 2. We are to carry out addition with them, not multiplication. Why? Between these 2 and these 2, just one sign. These 2 and these 2, just one sign. These 2 and these 2, one sign coming between them, nothing else. Therefore, we conclude that with all these 5 operations, only one is not addition, and that one is this one. The rest are addition. Let us move on to the next one, how to recognize multiplication. Right? This is number 2, how to know that a particular number operation involves multiplication. It says, when multiplication is required, usually the number operations take patterns such as the following. It is not necessary to explain how to know whether what is required is multiplication or not without examples. What I'm trying to say is that it is better we use examples to learn how to know that what is required is number operation instead of trying to use only words. If we use only words to learn that, before we go to the examples, we must have gotten confused. So instead, let us learn by means of examples. We have just about 4 of them here. Look at this first one. Box times box. Please permit me to use box to represent a number or a term. That is a number here or a term here. That is also a number or a term here. And then between them is this sign. This sign is the most popular sign of multiplication. And so let this box have 3. Let this box have 7. And let this sign come between them. With that alone, we understand that this is multiplication. This is also multiplication. This is also multiplication. Therefore, this first one, which contains box times box, simply means a number times number. not minding whether the number is a variable or a constant. Examples I gave here are all constants. Examples I gave here are all constants. Let's look at example number 2. Box, then box again. This one is used especially when there is a multiplication going on between a variable and a constant, or a variable and a variable, but never a constant and a constant. Let us see examples here. Like I said earlier, let box represent a number or a term, either a constant or a variable. Here we have this x. Here we have this y. Because of that, x, y does not mean x plus y. It means x times y. We don't know what x is. We don't know what y is. But if we get to know what they are, what we are carrying out between them is multiplication. But imagine that you put 2 here and 3, and you just put 2, 3. Just put 2, 3. Nobody will understand that what is meant to be carried out between them is multiplication. Some, even I, will see it as 23. That is why it is not good to use this pattern to show multiplication between constants. But between constant and a variable, and between variable and variable. That is why all the 3 examples here contain such. xy, the next is cx, the next is 12y. This 12y is multiplying a constant by a variable, and then such like things. Example number 3 is this: box, then the next is bracket with nothing separating them. See it here. This box contains a number, either a constant or a variable. That will be this 3. And let this box also contain this 15. As long as a bracket exists between 3 and 15, we can call it 3 times 15. But imagine removing this bracket and still writing 315. That now will have a new meaning, no longer 3 times 15. I believe you know what that will turn to be. This is why this bracket is important, to separate constants from constants when they are multiplying. The next is that this box can be this x, that is a variable, and what is in this bracket is a sum, 3 plus y. Remember that a sum that is bracketed is also considered a term. All right, the next example is minus 7 bracket x plus y. All of them conform to this pattern. That is, something outside the bracket multiply the things in the bracket. The final one is this number d, bracket times bracket. We might even continue to say as bracket times bracket times bracket indefinitely, but we can do with just 2 brackets at the moment. Something in this bracket, something else in this bracket. Look at just 2 examples. I have 3 minus x in bracket, then bracket 4x plus 1. It means the content of this bracket multiplying the content of this bracket. This next example says 2x minus 5 bracket x plus 2. It means the content of this bracket multiplying the content of this bracket, and vice versa. It is believed that all of these examples will help you to know when to carry out a multiplication between numbers. Most importantly, just recall that whenever 2 numbers are written, especially variable and variable, or a constant and variable, and there is no sign written between them, the sign is sign of multiplication. Let us now move to the third one, that is how to know that what is required is division. And now that third one, how to recognize division. Division takes any of 2 simple patterns. It appears to be the simplest of all when it comes to recognizing whether it applies or not. What are those simple patterns? They are just 2. Look at the first one. Box divided by box. Anything can be in this box, but must be a term. Either a constant, group of constants, a variable, group of variables, or group of variables and constants. Anything can be in this box, but whatever it is, it must be called a term. So this box divided by this box, 6 examples here. 12 now is meant to be in this box, and 3 is meant to be in this box. And so this division is sign between them is sign of division. So this means 3 dividing 12, not 12 dividing 3. It is this that divides the space. The next is 18x divided by 6. So from this box, we get this 18x. From this box, we get this 6. And so this sign is also between them. Therefore, we have many more other examples that resemble this one. Second pattern is this one, that is box over box. So it means that this over is also a sign of division. This slash may not always mean division. Sometimes it might indicate a fraction, that is portion taken out of portion. But here it means something dividing something. It is the one below that divides the one on top. Therefore here 24 divided by 3 also means 3 dividing 24. This is 4 dividing 5x minus 3. And we have many more examples in line with this pattern. And now the fourth one, that is how to recognize mixed operations. As earlier learned, a mixed operation contains some or all of addition, multiplication, and division in one number operation. It is possible to see a number operation containing more than one type of number operation. We've learned earlier how to know that what is required is only addition, only multiplication, and only division. Now, if you see each of these things mixed up, are we going to know? Certainly, we should know that what is now required is no longer a pure addition, a pure multiplication, or a pure division, but a combination of either some or all of them. These 3 examples will highlight the point. Look at this first example, 3 bracket minus 8 divided by 12. What is required here is not pure multiplication. What is required here is not pure division. What is required here is not even addition. Instead, 2 things are required. 3 and minus 8 are to be multiplied, which means that this side of this expression is multiplication. And then what follows is division, which means get the result of this 3 times minus 8. When you get it, divide it by 12. Whatever you get is the answer. That means that in this operation, multiplication and division are to be carried out. This is number B, 3 bracket minus 1 plus 9 bracket minus 2, all over minus 1 minus 6. What and what are involved here? 3 bracket minus 1 is multiplication. 9 bracket minus 2 is also multiplication. Then, because we have this plus between these 2 expressions or these 2 terms, it means that we also have addition. It means get this result, and combine both of them. If you combine them, they now become one number above. Then you come down, minus 1, minus 6. We are to add minus 1 and minus 6. I hope you remember why what is required here is addition. So if you now add minus 1 and minus 6, you get one number, and you have gotten one number again before. You now have one number on top, one number below. Then this slash is what you're going to carry out last. What does it mean? It is a sign of division. That means divide that single number you got from these by these ones that you have made to become one number. So a single number below, divide the single number above. The third one goes this way. 7 plus 2 minus 5 bracket minus 2. This is also a mixed operation. Why? Between 7 and 2, no other sign except this plus. Therefore, between 7 and 2, what we're going to carry out is addition. Then this is minus 5 bracket minus 2. This 5 is going to multiply this minus 2. Do not be tempted to start saying 2 minus 5. Please, this minus 5 has no link with this 7 and this 2 until it has become one number with this minus 2 here. Therefore, this alone is a multiplication, while these two are addition. What it means is that if you get the sum of these two and make them become one number, that is, that one number is a sum, you then get the product of these two, that is minus 5 times minus 2. If you get an answer from this multiplication and get an answer from this addition, you now join both of them by addition. These are just few out of several cases of mixed operations that we can have in real life. It is believed that you understood how to recognize types of number operations, how to know that a particular number operation is addition, multiplication, division, or mixed operation. Time has come for you to test if you really understood. Here comes the checkpoint. For each of the following number expressions, determine whether addition, multiplication, division, or mixed operation is required. See them here. 1, 5 minus 7. 2, 5 bracket minus 7. 3, minus 3 times minus 1 times 9. 4, 36xy over 9x. The number 5. 2, minus 5 bracket minus 5. Number 6, minus 1, minus 1, minus 7, plus 19 over minus 2, minus 3. Number 7, 5 times 2 plus 9 times 3. Number 8, 42 divided by, in bracket, 3 minus 10. Please, where possible, try to evaluate. But the most important thing here is for you to know what is exactly required. Whenever you determine that what is required is a mixed operation, it is important, especially that you try to find out what the answer is by trying to interpret the operation and trying to carry out the operation accordingly.